Let us take this problem. It says that, okay, here there is a 2 kg mass, here there is a 4 kg mass. They are connected with a single string. The coefficient of friction here is mu2, here it is mu1. And this angle of the slope is 30 degrees. Since they are connected with a single string, so tension in the string will be same everywhere. Says that tension in the string is 16 Newton. So tension is equal to 16 Newton. And the tension is also the tension here, is also the tension here. Acceleration of the each block is 0.5 meter per second square. So this block is also coming down with the acceleration of 0.7 second square. This one is also moving with an acceleration of 0.5 meter per second square. The question is find the friction coefficient at the two contacts. That means we have to find out mu1 is how much, and second question is mu2 is. That's the only question. Now, we take the two blocks one by one. We consider the 4 kg block. Consider the 4 kg. Now, what are the forces on 4 kg block? This has got a downward gravitational force mg, has got a normal component of the gravitational force. It has a inclined component of the gravitational force mg sine. And of course, it has got a reaction force R, and here it has got a tension T on the string. We find out the value of R. The reaction force R is equal to, obviously, reaction force R is equal to mg cos theta, n theta. N is 4 kg given, n, and cos theta is √3 by 2. This is equal to 20. Then what is when this body of 4 kg is sliding down, then there is a frictional force F upward. This frictional force F is equal to this is equal to, we have to find out the value of mu. This value is mu2. Value is mu2, it is given in the picture. Mu2 into R is given as 20√3. Then we write force equation on the 4 kg block. Force equation on the 4 kg block. Find the downward force mg sine theta. We find sine theta. The backward force is tension T. Another backward force is the frictional force A is equal to mass 4 into A is 0. Right? From this, 4 kg, G is 10, sine theta is half, minus tension T is given 16 Newton, tension T is given 16 Newton, and as 16 Newton minus this F is, this Fk is 20 root 3, Fk is 20 root 3, is 20 root 3 is equal to 4. Now A is also given as 0.5, where A is given 0. Now Fk as a value, Fk is mu 20 root. So you should write here, instead of just 20 root 3, you should write here Fk is solve this equation, we'll find that mu 2 is equal to 1. Now to consider only the 2 kg body. Consider the only the 2 kg body. Find the frictional force A is equal to the reaction force here is nothing but 2 into 10 is equal to 3. If we write the forces in the horizontal direction, then we find the horizontal force T minus force against the motion is F, which is 20 mu1, will be equal to mass 2 kg into acceleration A. Acceleration A is given and frictional force is 20 mu1, tension is also given. So tension is 16 Newton minus 1 is equal to 2 into the, and mu1 is 0.75. Now, we shall go to another small question. In fact, in this friction chapter, I have observed the arithmetic are quite easy, but you have to organize the answer first. You have to just think first how you solve this question. If you think first if your thinking is proper, then you will not have much problem in making the solution. This problem says that the friction coefficient between the table and the block, as shown in figure, is 0.2. So mu here is 0.2. Find the tensions in the two strings. There is one string T2, there is another string T1. Let's say these are the tensions. Since there are two strings, so there will be two different tensions. First we find, now this is a 15 kg block, so we expect this to come down. Let's say it come down with an acceleration A. This is only a 5 kg block, this will go up. And let us say this acceleration is A. Of course, acceleration of the whole body will be the same. Upward acceleration is same, A. And for this block, the acceleration towards left is also A. Let's find out the frictional force FSA. This frictional force FSA is 0.2 is given here 0.2 multiplied by what is its weight? 5 kg. So 5 multiplied by G equal to 10. So when this block is moving left, there is a frictional force towards right opposing the motion, which is 10 Newton. Now we have to take the three blocks separately. For that, let me do one thing. Let me mark these blocks. Say this block is A, then it will be easy to understand. This block is B, and this. Once we have marked them, then we consider block A. Consider block A. Block A is this block. What do you find? Downward force is 15G. Minus upward force is tension T1. This has to be equal to mass put in into acceleration A. And let's say block B. Take block B. From block B, what do we get? Upward tension is T2 minus downward force is IG is equal to mass M acceleration A. These are the two equations we get. From these two equations, you can add 15G. If you just add these two equations, I write these two equations, then we find 15G minus T1 plus T2 minus 5G is equal to 15A plus 5A is equal to 20. Then find out T1 minus T2 is equal to 5A plus 10. Let's say this is equation 1. From here you can find out 5A plus 2 because the value of G is 10, you know. Then, if we go to the block C, then we find block C is moving towards left, and the force towards left is T1, minus force towards right is T2, minus frictional force F will be equal to its mass pi into acceleration A. Mass pi into acceleration A. I am sorry that I have made a mistake here. This will not be like this. T1 minus T2 will be equal to 100 minus 28. This is equation 4. And from this equation, we find T1 from this we find T1 minus T2 minus F is equal to 5A. So what is F here? F we have already found 10 Newton. So from here we find T1 minus T2 is equal to T1 minus T2. T1 minus T2 is equal to 10 plus 5. Okay, this is equation 2. From this equation 1 and 2, from equations 1 and 2, can easily find out the values of T1 and T2 by eliminating. Easily find out the values. We find that you will find the values. Deductions you can do at home. A is equal to 5 meter per second square. We will also find T1 is equal to 96 Newton. We will also find T2 is equal to. Your answers are 96 Newton and 68 Newton. Next episode, we shall take the next question.